Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we are discussing mathematics class 12th, and the chapter that we are currently dealing with is integrals. In integrals, it's time to continue further with definite integral, and this is exercise 7.9, which is based on the fundamental theorem of calculus, which says, okay, definite integral can be calculated by first calculating the indefinite integral and then putting in the limits, right? So along with the questions, we'll be seeing the concepts, but the important thing before going through this exercise is for you to have a fair amount of idea about indefinite integrals, right? Especially the first few exercises were very, very important, very critical. So all of those will be used over here. Continuing further with this particular exercise 7.9, we'll move on to the first question. Question number 1 says, evaluate this particular value. So we have integral from -1 to 1, x plus 1 dx, I, which is integral -1 to 1, x plus 1 dx, can be done as, okay, integral -1 to 1 is okay. X plus 1 can be integrated directly, there's no need to write that. Okay, there's no need to write this. Integration is very simple over here. X plus 1, the integral of x will be x square by 2, and the integral of 1 will be x, and you'll have to put the limits -1 and 1. And how do we put the limits? We substitute this limit and subtract this value. FB minus FA is what you do, right? What are we doing? If integral fx dx is equal to capital Fx plus c, if this, then integral a to b fx dx will be equal to f of x a to b, this is how you mention the limit, this is equal to f of b minus f of a, this is equal to this. Yes, that's what we have, and this particular idea will be used over here. So substitute this 1, this becomes a 1 by 2 plus 1, minus, substitute this -1, this becomes a 1 by 2, and this becomes -1. So 1 by 2 plus 1 minus 1 by 2 plus 1, the overall value will be 2, and that is my required answer for this particular question over here. Is that all? Yes, that's all. The second question says integrate, evaluate integral from 2 to 3 of 1 by x dx. How do we do that? Once again, not very difficult. From 2 to 3, if I want to integrate this 1 by x dx, the integral of 1 by x is log modulus x, and substitute the limits from 2 to 3. Now, next time onwards, I'll substitute this limit by putting up a single bar instead of writing the x square brackets. This is the preferred form in which we generally deal. This is log mod 3, which is 3, minus log mod 2, which is 2. And this is actually log of 3 by 2. That is my required answer for this question. Right, log of x minus log of y is log of x upon y. That's all in this second question. In the third question, we have a huge polynomial inside this. So we'll substitute, we'll first integrate 1 to 2, 4x power 3 minus 5x square plus 6x plus 9. This integral is not at all difficult. The integral of this whole expression, 4x cubed, the integral will be 4x power 4 upon 4. Minus 5x power 3 upon 3 is this integral. 6 times x square by 2 is what you'll get over here, and 9 times x is what I'll get over here. Substitute limits from 1 to 2, and what do we get? This is simply x power 4, so this becomes 2 power 4, which is 16, minus this is 5 by 3 times 2 power 3, which is 8, plus 6 by 2 is 3 times x square, which is 4, plus 9 times 2 is 18, okay, minus 1 times 1 power x power 1 power 4 is 1, minus 5 by 3 plus 6 by 2, which is 3, plus 9 is what I get over here. Is that okay? Yes. Now, let's simplify this further. This is 16 minus 8 times 5 is 40 by 3 over here, plus 4 times 3 is 12, plus 18, minus 1 plus 5 by 3, minus 9 and 3 will be 12 actually. Let's add them together. This is what you'll get. And 12 goes with 12, as you can see. So 16 plus 18, what is that? 16 plus 18 will be 34, minus 1 is 33, and minus 40 by 3 plus this will be minus 35 by 3. I can add them together. This is 99 minus 35 upon 3, which simplifies to, okay, this is 6, 4 upon 3 is the required answer for this particular question over here. This is the third question for us, And that's the final answer for this third question. In the fourth question, we have integral 0 to pi by 4 sine of 2x dx. How do we integrate this? Integration is not difficult. 0 to pi by 4. Okay, this is pi by 4, right? Sine 2x. The integral of sine 2x is easy. Sine 2x, the integral will be equal to minus of cos 2x upon this 2. Since you have a linear function, linear polynomial of x instead of x, you'll have to divide with the coefficients. This is what you'll get. This is the integral. Limits from 0 to pi by 4 is what I'll put over here. Minus cos 2 pi by 4 is pi by 2 upon 2. This is the first term. Minus, substitute the 0, minus cos 0 upon 2 is what I get. What is this? Cos pi by 2 is 0. So this is overall 0. Minus of minus becomes plus. Cos 0 is 1. 1 by 2. This is 1 by 2. Simple answer, 1 by 2. That's the correct answer for this question. Fourth question. Yes. In the fifth question, we have integral from 0 to pi by 2 of cos 2x. How do we integrate that? Not a difficult thing. I will be this. So 0 to pi by 2. Okay, the integral limits are no longer important if you can integrate this cos 2x. Cos 2x, the integral will be equal to sin 2x by 2. Put the limits from 0 to pi by 2. And what does that give me? This is sine 2 pi by 2, which is sine pi by 2 minus sine 0 by 2. This is what you get. What is the value of sine pi? Sine n pi is 0. This is 0 minus 0. The overall value will be 0. Pretty interesting. This integral is equal to 0. That's what you can observe over here easily. Question number 6 says integral from 4 to 5 e power x is supposed to be found. So I, which is integral from 4 to 5 e power x dx, the integral, the indefinite integral of e power x is nothing but e power x, and put the limits from 4 to 5. What does that give me? E power 5 minus e power 4. This is my final answer. At max you can take out e power 4 common, e minus 1. This or this is my final answer for this particular question over here. In the seventh question, we have integral from 0 to 4 pi by 4 tan x dx. So I is 0 to pi by 4 tan x dx. And what is this equal to? So integral of tan x is important. Integral of tan x, what is that? That is log mod sec x. Log mod sec x, you have to integrate from 0 to pi by 4. Put the limit 0 to pi by 4. Now this becomes log mod sec pi by 4 minus log modulus of sec 0 is what I have. What is sec pi by 4 equal to? Now sec pi by 4, cos pi by 4 we remember is root 2, 1 by root 2. So this is root 2. This is log of root 2 minus log of sec 0 is 1. And what is log 1? Log 1 is simply 0. So this becomes log of root 2, or this is 2 power 1 by 2, right? So that power 1 by 2 can come in the front, and this will be equal to or 1 by 2 log 2. This or this can be the final answer for this particular question. As you can see over here, that's all that you have in this seventh question. In the eighth question, we have integral of cosec x. Okay. So integral of cosec x, what is that equal to? So you remember integral of cosec x, indefinite integral of cosec x is important. And what is that? Log mod cosec x minus cot x is there, plus constant of integration. This is the formula, right? Integral of sec x is log mod sec x plus tan x, and this is cosec x minus cot x. Therefore I, which is equal to integral from pi by 6 to pi by 4 of cosec x dx, will become equal to, substitute the limits in this, log mod cosec x minus cot x from pi by 6 to pi by 4. By the way, there is another version of this. I'm not discussing that version because NCERT people haven't used that version, given that kind of a version, but there is another version in terms of tan, right? This can be simplified in terms of something called tan, right? What is this equal to? This is log of cosec pi by 4. Now let me write the value of cosec pi by 4 directly, which is root 2 minus cosec cot pi by 4. What is cot pi by 4? Cot pi by 4 is 1. This is what you have. This is the first term minus the second term, log of modulus. Cosec pi by 6 is important. Cosec pi by 6 will be 2. minus cot pi by 6. Cot pi by 6 will be root 3. This is what you get, modulus, and there's a bracket, right? So this becomes log this minus this, log this minus log this will be log this upon this, root 2 minus 1 upon 2 minus root 3. This or this, either this or this is your final answer for this question, right? Root 2 minus 1 is a positive, so modulus can be replaced with the normal bracket. 2 minus root 3 is also positive, modulus can be replaced with the normal bracket. This or this can be my final answer. Anyone can be given, right? That's the final answer for this 8th question, as you can see over here. In the 9th question, I have integral from 0 to 1 dx upon under root of 1 minus x square. Now, integral of 1 upon root 1 minus x square dx is equal to what? This is equal to sine inverse x plus c, or it is equal to minus of cos inverse x plus constant of integration. So I can use therefore I, which is integral 0 to 1 dx upon root of 1 minus x square will be equal to sine inverse x from 0 to 1, which is equal to sine inverse 1 minus sine inverse 0. Now sine inverse 1 is pi by 2 and sine inverse 0 is 0. This is equal to pi by 2. That's my correct answer for this particular question, 9th. The 10th question has integral from 0 to 1 dx upon 1 plus x square. How do we handle this? 1 upon 1 plus x square, the integral is tan inverse x. So this I from 0 to 1 dx upon 1 plus x square becomes equal to tan inverse x from 0 to 1. This is tan inverse 1 minus tan inverse 0. What is that? This is pi by 4 and this is 0. The overall answer will be pi by 4, as you can clearly see over here. The overall answer will be pi by 4 for this question. In the 11th question, we have dx upon x square minus 1. Integration of that can be done with the help of, there are two approaches. One is the direct formula, other is using the concept of partial fractions. So let's take a look at that integral first. Dx upon x square minus 1 integral. This is x square minus a square. If you remember the formula, dx upon x square minus a square, the integral will be equal to 1 by 2a log modulus x minus a upon x plus a plus constant of integration. This is 1 upon 2 actually. Let me get rid of this one. This is 2 into 1, which is 2 only. That's the formula, right? So therefore I, which is integral from 2 to 3 of dx upon x square minus 1 will be equal to 1 by 2 log modulus x minus 1 upon x plus 1 from 2 to 3. This is what you have. So 1 by 2 is okay. Log, substitute these values. This minus this, log of 3 minus 1 upon 3 plus 1 modulus minus log of 2 minus 1 upon 2 plus 1, the modulus is equal to what? So 1 by 2 remains as it is, yes. And in the curly bracket you have log of 2 by 4, which is log of 1 by 2, minus log of 1 by 3 is what you get. Is that okay? Yes. Log of x minus log of y will be log of x upon y. Let me simplify that. 1 by 2 log of this upon this. So 3 will come in the numerator. This will become 3 by 2 over here. And that is my correct answer for this particular 11th question, as you can see over here. In the 12th question, we have integral from 0 to pi by 2 cos square x dx. Now integral of cos square x. Let's take a look at integral of cos square x first. Cos square x is a higher power, cannot be integrated directly. We'll have to reduce that power to a lower power and go into multiple angles. So cos square x is 1 plus cos 2x by 2. Okay. This integral with respect to x. Right. We can use the limits also over here and maybe go ahead with the limits. I will be equal to 0 to pi by 2. Let's write this as this. And this further becomes integral from 0 to pi by 2. Okay, we can integrate that stage, so there is no need of integral sign. At this stage you can integrate it. The integral of 1 by 2 will become x by 2 plus the integral of cos 2x will become sin 2x by 2. There is a 2 already there, so this becomes this by 4. From 0 to pi by 2 is what I have. And what is this equal to? This becomes pi by 2, which is pi by 4 plus sin 2 pi by 2. Sin 2 pi by 2. What is that? Sin pi. Sin pi is a 0. Yes. 0.4 is okay. Minus. What do we have? 0 by 2 plus sine 0, which is 0. So the overall value is pi by 4 of this particular limit. That's the correct answer for this 12th question, as you can see over here. Question number 13 says evaluate the integral from 2 to 3 x upon x square plus 1. Now how do we handle that x upon x square plus 1? So you may recall this integral is slightly difficult. We will have to use some kind of substitution. So let's integrate separately first. This is I, this integral is equal to what? So this x has to be written as in the form of derivative of this. So derivative of x square is actually 2x, and this is what you get, right? And x square plus 1, if I substitute x square plus 1 is equal to t, what do I get? 2x dx is equal to dt. This particular calculation can be done orally as well. This becomes 1 by 2 integral from dt upon t, which is 1 by 2 is okay. This is log modulus t plus c, which is 1 by 2 log modulus of x square plus 1, which is same as simply x square plus 1, because this is always positive. Modulus will give a positive sign. That's okay. So this integral is equal to this. Therefore, I, which was from 2 to 3 x upon x square plus 1 dx, becomes equal to 1 by 2 log x square plus 1 from 2 to 3. This is what you'll have. 1 by 2 is okay. Yes. And in the brackets, I can deal with this. This is log of 3 square 9 plus 1 10 minus log of this 2 square 4 plus 1 5. This is okay. 1 by 2. This is log of 10 by 5. Log of 10 minus log of 5 is log of 10 by 5. And this is 1 by 2. This is log 2. Therefore, this is my correct answer for this 13th question, as you can see over here. Question number 14 says evaluate integral from 0 to 1 2x plus 3 upon 5x square plus 1. Now this 2x plus 3 upon 5x square plus 1, what is that? This is an integral of the form linear upon quadratic. So we'll have to integrate that separately. Let's integrate that using some kind of substitution. Let's find this integral separately. This is linear upon quadratic. So that linear 2x plus 3 has to be written as a times derivative of this denominator, which is 10x and plus some other constant b. 10a equal to 2 equals 10a. Comparing the coefficients of x gives me a equals 1 upon 5. This is 1 upon 5. Okay. What else? 3. The constant is equal to b. This gives me the value of b over here. Right. And once we are through with this, what next? Not much remains after that. We can simply write the numerator. This integral can be written as a times 10x. What is that? 1 by 5 times 10x plus b, which is 3, upon 5x square plus 1 dx. This will be separated to 1 by 5 times integral of 10x upon 5x square plus 1 dx, plus the other term will be 3 upon 5x square plus 1. Now instead of 5x square, since this is of the form x square plus a square, I'll write it as root 5x squared plus 1 squared. And now I'll apply the result for 1 upon x square plus a square directly. Here, what do I get? This can be substituted, this denominator can be substituted as t. So this becomes dt upon t after that. Okay. The integral will be 1 by 5 log modulus t, which is 5x square plus 1 over here. And plus this is 3. And 1 upon x square plus a square, the integral will be 1 by a tan inverse x by a. The only thing, instead of x, we have a linear polynomial of x and we'll divide by that root 5. So 1 by a tan inverse x by a, this, and divide by that coefficient of x, which is root 5, plus a constant of integration. This is what you get. So 3 by root 5 tan inverse root 5x is the final integral. These are the two terms of that final integral. Now I can substitute the limits, right? So I, which is integral from 0 to 1 2x plus 3 upon 5x square plus 1 dx, becomes equal to what? This 1 by 5 log 5x square plus 1 plus 3 upon root 5 tan inverse root 5x. This is the complete indefinite integral. Substitute the limits from 0 to 1. Okay, now let's do it. This is 1 by 5 log 1, this becomes log 5 plus 1, which is log 6, plus 3 by root 5 tan inverse root 5, minus, substituting this 0, so this becomes 1 by 5 log of 1, okay, log 1 is 0, and this is tan 0, which is 0 again, so this is 0, these two terms become 0. What do we get? 1 by 5 log 6 plus 3 by root 5 tan inverse root 5. That is my final answer for this particular 14th question, as you can see over here. Is that all? Yes, that's all in this 14th question. In the 15th question, we have integral from 0 to 1 x e power x square. And how do we handle this? So first we'll have to find that integral with the help of simple substitution. X e power x square dx. This integral I can be substituted with the can be simplified with the help of simple substitution. X square equal to t. What does that give me? 2x dx is equal to dt. Now using this integral will be replaced with x dx is dt upon 2, dt upon 2, and e power x square becomes e power t. The integral is e power t plus constant, yes, and this is nothing but 1 by 2 e power x square plus constant. That's the indefinite integral of this function, yes. And now I, which is integral from 0 to 1 x e power x square dx, the value can be found by indefinite integration 1 by 2 e power x square from 0 to 1. What is that? 1 by 2 e power 1 square minus e power 0 square. What is that? 1 by 2 is okay. E power 1 square is e power 1. E power 0 is 1. So this is e minus 1, and that is my correct answer for this question, as you can see over here. Question number 16 says, evaluate integral from 1 to 2 5x square upon x square plus 4x plus 3. How do we do that? So this is a quadratic upon quadratic, right? And in the denominator, you see, we can factorize this x square plus 4x plus 3 as x plus 1, x plus 3, right? So we can use concepts of partial fraction, but before that, we'll have to divide the numerator by denominator, yes. So all concepts of integration are being used in this particular exercise, yes. All concepts of integration are being used in this exercise over here. Let's take a look at this integral. Okay, this is a 5, and 5 will not impact much. Let's call I1 this. 5 can be taken outside that integral, that's not an issue. Let's call I1 this x square upon x square plus 4x plus 3 dx, right? We can write dx, but for that, first of all, I need to divide this by this, right? For dividing this is x square, right? At max, what I'll have is x square plus 4x plus 3 times 1, yes? And then you'll have to subtract 4x and subtract 3. This is what we are looking at, right? For dividing, this is what we are looking forward to. And what does this convert into? This is integral of 1 minus will come out common. 4x plus 3 will remain in the numerator. In the denominator, I'll have x square plus 4x plus 3 factorized into x plus 1, x plus 3. This is what you'll have, right? And now this expression can be simplified by using concepts of partial fractions as 4x plus 3 upon x plus 1 x plus 3 will be easily written as, a upon x plus 1 plus b upon x plus 3. Finding the values of a and b is the key, and we can find the values of a and b easily. A will be equal to what? You multiply throughout with x plus 1, this goes away, and you put x equal to minus 1. So this becomes minus 4 plus 3 minus 1 upon 2. So a is minus 1 by 2. B will be equal to what? So you multiply with x plus 3, this goes away, and you put x equal to minus 3. So this becomes minus 12 plus 3, which is minus 9 upon minus 2. Minus 9 upon minus 2 will be 9 upon 2. This is what you'll get, right? If you want, we can check as well, or you can use another idea, which is comparing the numerators, a times x plus 3, b times x plus 1. So a plus b, x is what you'll get. 9 by 2 minus 1 by 2 is 8 by 2, which is 4x. That's what you'll be getting. 3a plus b, b plus 3a. 9 by 2 minus 6 by 2, minus 3 by 2 will be 6 by 2, which is 3. Yes, that's okay. So values of a and b have been found. Yes, therefore I1 can be done as integral of 1 minus a upon x plus 1, which is minus 1 by 2 upon x plus 1. There's a minus over here, yes, and since this expression is equal to this, minus of this will be minus of a, which you have written, minus this will become minus b, which is 9 by 2 upon x plus 3 is what you'll get over here. This in the bracket dx. And now the indefinite integral is very simple. What you'll get is this is x, indefinite integral of 1 is x. This is plus 1 by 2 log modulus x plus 1 minus 9 by 2 log modulus x plus 3. Each and every term has been integrated plus a constant of integration. This is what you get. That's the indefinite integral I1. But mind you, we have found the indefinite integral after taking away this 5, right? Once we bring that 5 inside, we can easily find the value of I. So therefore, I is equal to 5 times integral of x square upon x square plus 4x plus 3 dx from 1 to 2. This implies 5 times, okay, integral of that x square upon x square plus 4x plus 3 is nothing but this expression. So let's write this expression, x plus half log modulus x plus 1 minus 9 by 2 log modulus x plus 3, right? And substitute limits from 1 to 2. That's what we'll do, right? No need of constant of integration over here. 5 remains as it is. In the bracket, what do we get? Substituting 2, this will become 2 plus half log 3. This is what you get. Minus 9 by 2 log 5. This is what you get. And subtract by substituting 1. So minus 1 minus half log 2, and minus of minus will become plus 9 by 2 log 4. This is what you get in the bracket. Okay, the round bracket over here. Yes. And can you simplify it further as well? Yes, maybe we can simplify it further. This is half log 3, half log 2. So this will become, okay, there's a 5 outside. In the bracket 2 minus 1 is 1 plus half. Log 3 minus log 2 will be log of 3 by 2. Okay. And minus 9 by 2 log 5. Minus 9 by 2 if we take it out common, log 5 minus log 4 will be log 5 upon 4. This is what you get. You can multiply with the 5 throughout. This will become 5 plus 5 by 2 log 3 by 2 minus 45 by 2. Very interesting. Log 5 by 4. This is what you get. Right? At max, what we can do is we can simplify it a bit further by taking this term having log 2 from here and term having log 4 from here and merging them together. At max, that's what we can do. Or this or that will be the final answer, but calculation from the point of view of integration and from the point of view of very long calculations, we have already seen the complete solution. That's all. Let me get aside. So you can take a look at the complete solution over here, and that's all that you have in this 16th question. Is that okay? Yes. The 17th question has integral of 2 sec square x plus x power 3 plus 2 from 0 to pi by 4. Yes, and how do we integrate this? Now integral of sec square x is pretty simple. X cube is also simple, 2 is also simple. So this integral from 0 to pi by 4 2 sec square x plus x power 3 plus 2. This indefinite integral is simple, and what will be the indefinite integral of this? Sec square x is the derivative of tan x. So this becomes 2 tan x plus x power 3, the integral is x power 4 upon 4 plus 2x, this is the integral, and integrating from 0 to pi by 4. What you get over here is 2 times tan pi by 4. Tan pi by 4 will be 1 plus pi by 4 power 4 upon 4. Now this is pi power 4, 4 power 4 times 4 will be 4 power 5, which is 2 power 10, which is 1024, plus 2 into pi by 4, which is pi by 2. Minus, if you substitute 0, this becomes 0, this becomes 0, this becomes 0, right? So this is what I'll be getting. That is 2 plus pi power 4 upon 1024 plus pi by 2. That is the correct answer for this particular question, as you can see over here. In the 18th question, we have integral from 0 to pi sine square x by 2 minus cos square x by 2. How do we deal with this one? So So sin square x by 2 minus cos square x by 2, this can be reduced to lower power and multiple angle very easily. Since cos x is cos square x by 2 minus sin square x by 2. Oh, cos 2x is cos square x minus sin square x, right? Using this idea, can I integrate that easily? Yes. Which is 0 to pi. This will be equal to cos square minus sin square will be equal to cos x. So sin square minus cos square will be minus of cos x dx. And integral of minus cos x, what is that? That's minus sin x. From 0 to pi is what we are interested in. What is that? This minus sin pi, which is 0. Minus of minus becomes plus. Sin 0 is 0. Okay, this becomes a simple 0. Yes, that's a simple 0, and that is my final answer for this 18th question, as you can see over here. In the 19th question, we have integral from 0 to 2, 6x plus 3 upon x square plus 4. Okay, so integration of this, how do we integrate this? This is linear upon quadratic. Yes, this quadratic cannot be factorized further, but this quadratic can be easily integrated. Yes, and since in the numerator we have 6x plus 3, which is a linear, we can write the linear as, let's talk about this integral, indefinite integral of this. This can be integrated by writing the numerator as a times derivative of denominator plus b. Find the values of a and b. 2ax is 6x, so that tells me a is equal to 2a is equal to 6, a equals 3, b equals 3 as well. This is what you get. Once you obtain this, therefore I1 becomes equal to integral of 3 times 2x upon x square plus 4 plus 3 upon x square plus 4. These are the two terms dx. And this 3, if you substitute x square plus 4 as t, then 2x dx becomes dt. So this is dt upon t, which is log, the integral will be log mod t. Plus this 3 remains as it is. You have x square plus a square in the denominator, dx upon x square plus a square, which is 1 upon a tan inverse x by a plus constant. This is what you have, right? Yes. Okay, so we have found the indefinite integral. Therefore I, which is integral from 0 to 2, 6x plus 3 upon x square plus 4 dx. What is this equal to? 0 to 2, 6x plus 3 upon x square plus 4. What is this equal to? So we can integrate this easily, and we have integrated, found the integral 3 times log of x square plus 4 plus 3 by 2 tan inverse x by 2. Right? This is the indefinite integral. Applying the limits from 0 to 2. What does that give me? So this is 3 times log of 2 square, 4 plus 4 is 8, plus 3 by 2 tan inverse 2 by 2 minus 0, which is 3 log 0 plus 4, which is 4, and minus 3 by 2 tan 0, which is 0, right? So this becomes 3 log 8 minus 3 log 4, that becomes 3 log 8 by 4. By merging these two terms, plus 3 by 2 tan inverse 1, which is pi by 4. And this becomes 3 log 2 plus 3 by 8 pi. That is the required answer for this particular 19th question, as you can see over here. Question number 20 says, evaluate integral from 0 to 1 x e power x plus sine of pi x by 4. How do we do that? So this x e power x is actually product of two functions, yes. So integration of this can be done with the help of by parts, one of the ideas, or there's a special integral related to e power x, we can use that. Integral of sine pi x by 4 is not a difficult thing, right? We can easily handle that. This is a linear function of x, and we can easily find the indefinite integral. So first focus on finding the indefinite integral of this function. Let's focus on I1, which is integral x e power x dx plus integral sine pi x by 4 dx. Let's separate these two integrals, indefinite integrals, outside. Right, so e power x, along with e power x you have x, okay, derivative of x can be created. What are we using over here? The special integral, which says integral of e power x times fx plus f prime x dx is equal to e power x fx. So this will have derivative 1. Let's reduce a 1 over here. So you have fx, and do you see that you have f prime x as well? Yes. So e power x fx plus f prime x, if you integrate this whole expression dx, this integral will be e power x fx, which is e power x times x minus 1. That's one part. Here, what are we supposed to do? This is a linear function of x, linear polynomial of x. So pi by 4 times x is a linear polynomial of x. You can integrate directly. You can integrate sine of pi x by 4 will be equal to minus cos pi x by 4. At the end, you'll have to divide with this coefficient pi by 4. This is what you'll be doing, right? Okay, so what does this become? This is minus 4 upon pi cos pi x by 4 plus a constant of integration along with this, right? This is what you'll be getting. Is that okay? Yes, that looks okay. Minus 4 by 5 cos of pi x by 4 plus c. That is okay, and this is also okay, right? That's a complete indefinite integral. Once you have found the indefinite integral, therefore I will be equal to integral from 0 to 1 of x e power x plus sine pi x by 4 dx. This is further equal to what? X e power x, the integral will be this e power x times x minus 1, and you have minus 4 by pi for this cos of pi x by 4, and the limits will be from 0 to 1. Let's substitute the limits, right? So substituting 1 e power 1 minus 1 will become 0. 1 minus 1 is 0, right? Minus 4 by pi cos of pi by 4 is what I'll get, right? That's one of the things. Then you substitute a 0, so this becomes, okay, this is the first term minus the second term. You substitute a 0, e power 0 is 1, 0 minus 1 is minus 1. This is what you get, minus 4 by pi cos 0 is what I'll be getting over here. This is the second term, yes? This is minus 4 by pi times cos pi by 4 is 1 by root 2 actually. This is what you have. And minus of minus 1 becomes plus 1. Minus of minus becomes plus 4 by pi, cos 0 is 1. So overall this value becomes 1 plus 4 by pi minus 2 root 2. 4 upon root 2 is 2 root 2 upon pi. That is my required answer for this particular question number 20th, as you can see over here in this question, right? That's the complete solution of this 20th question. 21st question says integral from 1 to root 3 dx upon 1 plus x square. How do we find that? So that integral is not at all difficult. We know that integral of dx upon 1 plus x square is actually tan inverse x, right? If there are limits 1 to root 3, then this integral will be from limits this to this. So this becomes tan inverse root 3 minus tan inverse 1. What's the value of tan inverse root 3? That is pi by 3, 60 degree basically. And here you have pi by 4, which is 45 degree. So pi by 3 minus pi by 4 is what is required. In the denominator you will have 12. This becomes 4 pi minus 3 pi, taking the LCM, this becomes pi by 12. Overall the value becomes pi by 12. The correct answer is option D, as you can see over here. With the help of this calculation, you get the correct answer as D. In the 22nd question, you have integral from 0 to 2 by 3 dx upon 4 plus 9x square. Now how do we handle this? So dx upon 4 plus 9x square, integral of this can be written as dx upon, this is 2 square plus 3x square. Oh, this is similar to x square plus a square, yes, except for the matter that instead of x you have a 3x. So we have a linear polynomial of x, yes, we'll divide with the coefficient of x at the end and integrate directly. 1 upon a square plus x square, the integral will be 1 upon a tan inverse x by a, which is 3x by 2, and divide by a 3 at the end. That's important. 3x, the coefficient is 3. Divide by this, and the limits from 0 to 2 by 3, limits from 0 to 2 by 3 will be applied over here, limits from 0 to 2 by 3. What is this expression, by the way? This is 1 by 2 by 3 is 1 by 6, which will come out from the bracket, you can say. And this becomes tan inverse 3 by 2 into 2 by 3, which is 1, minus tan inverse 0. This is what is required, right? So 1 by 6 is okay. This is pi by 4 minus 0, which is pi by 24. The value will be pi by 24, and that is my answer. Which option is pi by 24? This is option C. The correct answer is option C for this question, as you can see over here. With this, we come to the conclusion of this exercise 7.9 from integrals. This was based on definition of definite integral, and we used concepts of indefinite integral for solving all the questions over here. Till the next session, all the best.